now let's get into business. Grade 12 stuff. Impulse and momentum. So this is a grade 12 stuff. Impulse and momentum. So we're going to check what's momentum and what's an impulse. So remember, we did vectors and scalars, right? So momentum, it's a vector. Momentum is a vector. So that means momentum has a direction. So what's momentum actually? What's momentum? Any object that's moving has a momentum. So if only the object that's moving has a momentum, so what's the cause of momentum? Because an object that doesn't move doesn't have a momentum. So if an object starts moving, that means it has a momentum. So what's the cause actually of momentum? So we can come up with something. An object that's not moving, what's the velocity of that object? That velocity of that object is 0. The velocity of object, of state object, I'll just use as for static object, is 0. And the velocity of moving object, it's unknown. It has a velocity. That object is moving. So okay, we understand now that if an object is moving, it has a momentum. But if it's a stationary, it doesn't have any momentum. Alright, so we can relate momentum to some concepts. Any object, we know that any object has a mass. So that object that's moving, that object must have what? Velocity. Object must have a velocity. In order to have a momentum, the first thing is a mass. We already know that each and every object has a mass and velocity. Two things to have a momentum. So therefore we're saying it's a momentum of the object. So actually we can just say a momentum is just a power of object, because an object that has a higher momentum, that has a higher mass or higher velocity, it also has a higher momentum. So we can say that actually just a momentum is a power of object or a tendency of object to stop. Because if that object has a high momentum, it's going to take a long to stop if it's moving. But it has a lower momentum, it's easy to stop that object. So it's easy to stop an object that has a 10 momentum than to stop an object that has 20 momentum. So let's see. Therefore, momentum, since an only object that it's moving has a momentum, therefore momentum is going to be represented by small letter p. So that small letter has a bar on top. Who can tell me that? What's the meaning of that bar? Who can tell me that? Leave the comment below. I'll see it. So it has a bar, but here now want to the formula for momentum. So formula for momentum is represented by a small letter p. It's given by mass multiplied by velocity, and also velocity as a bar. So you have to give me a comment of why this thing has a bars. So now let's define momentum. We already know the formula because we said any object that's moving has a momentum, and that object must have what? A mass. So here we have a mass and velocity. It's a product. So what's the momentum by definition? Is a product of body mass and velocity It's a product of body mass and velocity. That's a definition of momentum. So what's SI units for momentum? Who can tell me that? Feel free to pause the video and try. From this one, what can you conclude from this? What can you conclude with the SI units for momentum? So since this is a mass multiplied by velocity, therefore the SI units for momentum is going to be kg times meter per second. You see, what's the units for velocity? This meter per second. What's the units for mass? It's kg. So this the SI units for momentum. It's a product of mass and velocity. So therefore, even the SI units is a product of mass units and velocity units. So that's it's a units for momentum. So example, let's do one example for momentum. Let's just do one example for momentum. A car has a mass of 108 kg. So this car has a mass of 108 kg and is carrying a 70 kg driver. It has a constant velocity of 3 meter per second west. So momentum, we said momentum is a vector, right? I said momentum is a vector here. So since it's a vector, that means it's pointing to some direction. So here's west. So that means if we remember our compass, we remember this is north, this is south, this is east, and then this is west. So therefore the car is going this way. The car is going this way. So this is the direction of the car. Then first question says calculate the driver's momentum. Okay, so I will say P, which stands for momentum, is equals to mass multiplied by velocity. I'm given a mass, yes. Do I have a velocity? Yes, I have. So I will just say mass, and then you have to read questions carefully. One of the things that make most of students in grade 12 to fail, or in any institution or any grade, it's because of rushing to a question. Here it says calculate the driver's momentum. You can rush and take 108 and put here as a mass, or you can rush and take 108 and add 70 and put here as a mass, and that will never ever give you a right answer. You'll just get chopped. So let's see, a mass is this one. Mass of a drive, it's 70. So 70 multiplied by velocity of the drive is 3. If you are inside the car and then the car is moving with a 3 meter per second, what's your velocity? Your velocity is also 3. We're calculating the momentum of the driver, not momentum of the car. The driver has a velocity and a mass, so he has a momentum. So what's that? That's going to give us 210. So that's 210 kg meter per second. So that's as a unit. Then the second question say draw. Oh, sorry, we have to give the direction here. We have to give the direction for this one. So since it's positive and the car is going west, so always momentum points in the same direction as velocity. Points in the same direction as velocity. Points in the same direction of velocity. Okay, so let's move on. The second one says draw and label the driver's velocity. You can see it's here. Draw and label the driver's velocity and momentum vectors. So driver is going west. The driver's momentum is going west. So let's start with the momentum. So here is going to be momentum, diagram, momentum, and then this one is going to be velocity. So let's draw that and label it. So momentum is going this way. So here you know how to draw a vector. A vector, use a head to tail. So this the head and then this a tail. So what's that for momentum? It's 210 kg meter per second. So that's your momentum from here to there, because going west. What about the velocity? Velocity is also the same thing, because it's 3 meter per second. Where it's going this way, it's going west. So both of them are going in the same direction. So the last one says calculate the momentum of the driver car system. So here it's where you're going to add the mass. So let's say the mass for this momentum is going to be 180 as we got, plus 70, so kg. This is going to be the mass, because they said what? Driver car system. So you're considering the momentum of a driver and the momentum of a car at the same time. So what's going to be the momentum? P, we're going to say P, it's M multiplied by V as always. So we're going to substitute this M is going to be this m multiplied by, since this is 250, then we're multiplying it by 3, then we're going to get 750 kg meter per second. And then, as I have said, the momentum is directly proportional to the mass and velocity. So if you increase the mass, the momentum increase. That means the harder to stop that object. So if a cab that has 14 passengers, which these are the seats for takes. So a cab that has 14 passengers and a cab that has 22 passengers, and another one, this is a sprint, and a sprinter that has 22 passengers. Even if they have the same mass, these two vehicles, but the one is going to have high momentum, which is this one. So that means if an accident is about to occur, the driver of a cab press the brake, is going to stop faster than the driver of a sprinter. So take care of these things when you're traveling. If you are in a car that has a higher momentum, you are safe sometimes you're not safe. But if you are in a car that has a lower momentum, it's easy to stop it if an accident is about to happen. So now let's do the change in momentum. So since we said that the momentum, it points in the same direction as the velocity. As you know, if an object bounces off, it changes the direction. So also the momentum is going to change the direction. And since we have the change in velocity, therefore can I have the change in momentum? What's stopping us to have that? We have the change in velocity, then we can have the change in momentum. So what's the change in momentum? Change in momentum actually is just the momentum final minus momentum initial. So this is the change in momentum. And what's momentum? Momentum actually just mass multiplied by velocity minus mass multiplied by velocity. So since this is going to be velocity final, this is going to be velocity initial. So this is just a change in momentum, and we use this symbol change in P to represent that, which is m. We can take m off, and then v final minus v initial, which you can move it further to this, multiplied by change in velocity, just like that. So the change in momentum is what we call impulse. So what's an impulse? Impulse is a change in momentum. That's an impulse. So let's do one example for the change in momentum. It says a tennis ball with a mass of 57 gram is traveling horizontally at 20 meters per second. So what's the mass of that object? We already got that. The mass of the object is 57 gram. The v initial is traveling at, v initial of the object is going to be 20 meters per second. And then the ball is struck by a racket and moves horizontally at 30 meters per second. So that means a racket, a racket, and then strike that the ball, and then the ball moving at 30 meters per second in the opposite direction. So therefore the v final, here we have to choose the direction. So let's take the first direction as positive. So therefore that means the v final of this object is going to be minus 30 meters per second in opposite direction. Then it says calculate the change in momentum of the tennis ball. So now to calculate the change in momentum of the tennis ball, I'm going to use that formula for impulse. Change in momentum, just a mass multiplied by velocity final minus velocity initial. So what's the mass? We have to convert that 57. So we're going to divide that by 1000. So we're going to say 57 divided by 1000. So which mass is going to be 0.057 kg. So that's going to be your mass. So if that is your mass, then now you're just going to substitute here 0.057, and then velocity final, it's minus 30. Velocity initial, it's 20. It's 20. Then you're going to get a negative answer, 57, and then minus 80 minus 20. So the momentum of object is minus 2.85 kg meter per second. So therefore can conclude by saying the momentum of that object is the same as 2.85 kg meter per second in opposite direction. As they said, opposite direction as they said the opposite direction. So let's do the last one. Let's do the last question. It says draw a vector diagram for initial momentum, final momentum, and the change in momentum. So now we have to draw that vector diagram. So how to draw that? So draw a vector diagram for initial momentum, final momentum, and the change in momentum. So initially the object was going, let's say the object was going in this direction. We're not given, but we just choose any direction. So therefore initial momentum here it's going to be for initial momentum, and then initial momentum we just have to get the tail, then the head, this is P, go in this direction. Then final momentum, and remember that when the object bounces back, it's moving with a velocity that's higher than the velocity that had initial. So remember that momentum is directly proportional to velocity. So this vector is going to be, if we can do this to here, this vector is going to be shorter than this one we're drawing now, because this momentum here, this is momentum x final, this is momentum x initial. This one has a higher speed than the first one. So after this, what's the change in momentum then? So for the change, then here we're going to draw one for change in momentum, So the vector for change in momentum is going to be this one that's going this way, and then from here you're going this way. So you see, this is the momentum x initial, this is the momentum x final, px final, and then here you have the space that's left, this space here. So this space is for change in momentum. So this is going to be the change in P. So that's a change in momentum. So the change in momentum is going this way. The change in P always points in the same direction as the change in velocity. If you can find the change in velocity, it's pointing in this direction also. So this is the change in momentum. Okay, thanks for watching my video. I'll see you next time.